Hello, I'm Will Bachmeyer,
I'm Waylon Weeks.
and today we're going to show you the Easy Paint brush dryer. So, where we started with getting our problem is I personally paint miniatures for a game called Warhammer, and when you're painting these models, one of the things that you have to do, which is kind of annoying, is whenever you want to switch colors but keep using the same brush, you have to completely clean the brush off to get all the old paint off. So that means you just have to have a cup of water. You just wash it off until all that paint is off, but then your brush is wet and you have to get it dried off before you can start using it again, because you use it when it's all wet, it's just going to water down the paint to try to use it, and it's not going to paint well. So what you have to do is either you have to use a towel and rub off the towel, which isn't the greatest at drying it, and also it runs the risk of damaging your brushes, especially if you have some really nice fine veto brushes. You have to be really careful about that. Or the other way is just shaking it dry, which is annoying, doesn't work that well, and just gets water everywhere. So we wanted to make a product that can clean your brush easily without the risk of damaging it or getting water everywhere, and that is what we've done with this product, and now we're going to demo that for you.
Okay, so here's our final design. Electronic housing sitting on top of this bottom of the outer cover. We've got the top of that and then also the bottom here. Wires running from that electronic housing through the bottom of the outer cover to the outside would be the power, and then also the on and off switch for the mechanism. We have the DC motor sitting on top, connected to that motor coupler, connected to that 3D printed brush clip, which holds the brush. So now we'll demo this by plugging it into the wall. There it is. And we're gonna wet the brush here. And then we slide that wet brush there, and then we're gonna put the outer top on top of the mechanism. And then we will run the mechanism. As you can see, it's water beads coming off, sitting on the outside of that cover. Usually let it spin for about 10 or 15 seconds, and that should do it. There we go. Now, take the top off, and we have a dry brush. Okay.
Okay, and then now we're going to show you how we actually built the product. So, first talking about the code, it is pretty simple. This is just the logic flowchart we made for the code. If you switch the switch on, the Arduino will read that, and then it will write to the DC motor to run at full speed. If the switch is turned off, Arduino motor will read that, and then write a speed of 0 to the motor so that the motor will stop spinning. So then, looking at the actual code, this is the entirety of the code, so you can see it's pretty short and easy. You just have to set up the switch and the button, and the pins, set a variable for the motor speed, then set up the pin types for the motor and the switch. And then the code in the main loop, you just read the button. If it is inputting a signal of 0, it means it's on, writes a speed of 255 to the motor. Otherwise, if it's not reading an input of 0, it writes a speed of 0 to the motor. And then looking at the wiring diagram, so you just have the switch, which is wired to a pin and ground, which is simple. The more complicated side of that is then the motor. So you have the motor that has to be wired with a transistor, because the transistor allows you to be able to write variable speeds to the motor instead of just writing it on or off. And then so you have that wired to a pin with a resistor, and then you also have to wire it to a diode, which prevents the motor from feeding back voltage into the Arduino, because when you turn the motor off right at speed 0, it'll keep spinning a little bit with the momentum it already has, and when it does that, it'll create a voltage that runs back into Arduino, which can potentially damage it. So you have the diode there to protect that from happening, and it just blocks the voltage. And then moving into the physical side.
Yeah, so we had 3 components that we computer designed, that being the brush clip and then that motor housing, which was the top and bottom. For the brush clip, we designed it to slide the brush in on the side and then also be able to flex, to be able to not break when that brush is slid in, and then also return back to place once that brush is taken out without any damage. For the electronic cover we have here, on the left is the bottom, which has the 3 pieces jutting out of it to mount the Arduino and hold it in place, not let any wires or anything get everywhere. And then the breadboard will be mounted with an adhesive on the left side of it. And then we also have that hole running through the bottom of it that is used to run the power, and then the button wires through to the outside so the user can power the mechanism and also turn it on and off. Then we have the top of it on the right side with that kind of curved design so that if any water ends up on there, it will hopefully fall down to the bottom. And then we also have the cutout at the top where that DC motor can lay in there and project to the outside so that the brush can be mounted on it. We ended up iterating through a couple of designs of these, but these are the finals printed out of PLA because we didn't need a ton of strength, and that's the most readily available printing material. On the left side, you see the brush clip holding the brush there, mounted to the motor coupler, which is then mounted to the shaft of that motor. Very secure. And then it's also, as you can see, the DC motor is mounted with a little bit of hot glue. The tolerance worked well with how we designed it for that DC motor to sit in there snug, but we just wanted to hot glue it for that little bit of extra strength. Then on the right side, you see the electronic top with the motor just wired down into the rest of the electronics on the bottom there with that breadboard and mounted to the bottom with an adhesive, and then that Arduino mounted onto those pins, and then that cutout through the bottom running those wires, the power and the button on and off. Thank you for watching.
Thank you.